Welcome. So I'm going to review through the skills needed to do the geometry honors project. Right? And so I'm just going to do a similar problems. You'll write your own equations and graph your own lines, but at least I'll go through the steps for each of these things. Right? So the first problem says to graph a horizontal line with an equation. So I can't use a ruler up here. I'm going to use a line tool. I could put the horizontal line anywhere I want. Maybe I'll put it down here. Oops, where did my line go? Oh, there we go. Now, I want it going through an integer value, otherwise, oops. I'll never be able to figure it out. Close enough. You'll do better than me. I don't want to take all the time moving the thing. So this is going through on the y-coordinate at -2. So this line has an equation y equals -2. All right, so horizontal lines go through the y-axis, so they're y equals. Vertical lines go through the x-axis, so they're x equals. So let's graph a vertical line. I'm going to graph it right here. Oh, perfect. Exactly where I wanted it to be. And I'm going to put arrows on it because it's going to keep on going. Right? And so that's going through 1, 2, 3, 4, 5, 6, 7, -7. So this is the line y equals -7. There's that equation. All right, so I'm going to graph a line with a negative slope. It can be any negative slope. It just has to go down left to right. I'm going to go through a point to make it a little easier for me to write my equation. And so you do want to go through a point. I'll go through that point. That looks like a good point. All right, and there we go. Now I don't care where it goes through on the y-axis, so long as it goes through that point. Because if I have a point, I can write the equation of the line. There's my line with a negative slope. So this is, if you're following along with the problems, this was number 1, this was number 2. Now I don't want to see y equals -2 and x equals -7. Make yours something different. And here's number 3. There's my line with a negative slope. We need to write the equation in point-slope form and slope-intercept form. So that's why I went through a point. That point is -3, 1, 2, 4. So the easiest thing for me to do is to write it in a point-slope form and then simplify it. Now it's clear that my line does not go through a nice integer value on the y-axis. Right? So I definitely wouldn't want to trying to estimate what that point would be in slope-intercept form. However, no matter what my line looks like, once I write the equation in point-slope form, I could just simplify it, and I could, when I simplify it, it'll be in slope-intercept form. So in point-slope form, the formula is y minus y1 equals m times x minus x1. So I have to find, I have the point, there's x1 and there's y1. I do need the slope. All right, so I'm going to go with the points I can see pretty well. All right, if I extended the graph, let me actually extend the line just to make sure. Because you want to make sure you have 2 good points. I'll make sure they have 2 good points. All right. And is it okay for you to choose 2 points and then connect those? Absolutely. So you don't just have to, what I should have done is graph the 2 points, remembering I need the slope, and then draw the line through the 2 points. So I'm going to suggest, to make it easier on yourself, graph 2 points, connect those with the line, and use that to write your equation in point-slope form. Now I can either use the slope formula or I could count it on the coordinate plane. I don't care which one you do. I use the slope, I'll do both. All right, so This point here is the point negative 1, 3. That's a negative 1 there. So if I'm using the slope formula, actually let me not do it there, otherwise I'm not going to have any space. We'll do it over here. Slope formula. To find the slope, this would be, so I'll start with the negative 3, 4. So 4 minus 3 divided by negative 1 minus a negative 3, which is the same as 4 minus 3 divided by negative 1 plus 3. So that's going to be positive 1 sorry about that. So 4 minus 3, negative, oh wait, sorry. I grabbed the wrong values when I was looking. The 4 minus 3 is good, but it should be negative 3. I transposed the points. So if this is my first point, I'll use x1, y1 first, then I'll use x2, y2. So 4 minus 3 divided by negative 3, because I started with 4, negative 3 minus a negative 1. I accidentally transposed the points. So 4 minus 3 is 1. Negative 3, that would be negative 3 plus 1. And so that's going to be negative 1/2. Right, because negative 3 plus 1 is negative 2. Now you could also just count those. Down 1 to the right 2 is negative 1/2. All right, so in point slope form, this is, and I'm going to use negative 3, 4, I decided. That would be y minus 4 equals negative 1/2 times x minus a negative 3. So that's y minus 4 equals negative 1/2 times x plus 3. There's your equation in point slope. You're done. I had a double negative, so I simplified. You should simplify double negatives, but you don't have to do anything else. So now to write my equation in slope-intercept form, I'm just going to simplify. So here's the equation in slope-intercept form. I'll just put SI for slope-intercept form. All right, so we're going to isolate y. So first, I need to distribute the negative 1/2. Negative 1/2 times x is negative 1/2 x. Negative 1/2 times 3 is negative 3/2. Now I need to add 4 to both sides, but I need to have 4 have a denominator of 2. If I have 2 in the denominator, I have to have 4 times 2 in the numerator. So that's going to be y equals negative 1/2 x plus 5/2. There's our equation in slope-intercept form. So slope-intercept form and point slope form. Right? Number 4, and I think I'm going to do number 4 on the next page because I'm running out of space. So let's just clone this page. And we'll go right to number 4, since we've already done number 3. Oops, and we made 2 of them. That's okay. We'll need it. Let's clear the ink from the page. All right, and we'll get rid of all these lines too. Oh no, instead I cloned it. Definitely not what I wanted to do. Whoops. There we go. Oh, you know what? That's going to be my, I'm going to just use that for my slope with a positive line. I'm just going to turn it around. All right, so this time, let's graph a line with a positive slope. I'm just going to pick that point there, and of this point right here. Now I'm going to make mine just a little harder maybe than you'd make yours, just to have some harder ones for us to practice with, since it's me doing the work. All right, so here I have the point -1, -2. I'll put arrows there because it's going to keep on going. And I have the point +1, 1. All right, so I need the slope formula to write the equation of the line. You could use the slope formula, or you could just count. I'll do both. All right, so the slope, and you can be first and you can be second. All right, so actually, you know what? You be first. X1, Y1 will be first, and oops, X2, Y2 will be second. All right, so we have 1 minus a -2, right? The y coordinates first. And just a reminder in case you forget. Y doesn't matter who y2 is and who's y1, but 1 point, the y's go in the numerator and match them up with the x coordinates in the denominator. So I have 1 minus a -2 and 1 minus a -1. And it won't work if you transpose it, like I accidentally did on the last slide. So that would be 1 plus 2 and 1 plus 1, or 3/2. And we can count that up 1, 2, 3, to the right 2. That is the slope 3/2. So it doesn't matter which way you do it. All right, so now we can write the equation of that line in point slope form. I'm going to use this point, the 1, 1. And then we can simplify to slope intercept form. So I have in point slope, I have y minus 1 equals 3/2 x minus 1. And then slope intercept, I just have to distribute and isolate y. So I have y minus 1 equals 3/2 x minus 3/2. Multiply both of those by 3/2. And then I just need to add 1 to both sides. But I need the denominator to have a 2. So if 2 is in the denominator, 2 times 1 has to be in the numerator, right? So 2/2 is the same as 1. And it has a denominator that matches 3/2. So we have y equals 3/2 x minus 1/2, because -1/2 plus -3/2 plus 2/2 is -1/2. So there are my answers for question 4. And by the way, I can post the whole slide. So, all right, let's look at number 5. So 5 says graph a pair of parallel lines with equations written in slope-intercept form. If you're going to be writing the equations in slope-intercept form only, I guess it makes sense to go through the y-axis to make it easier, right? Say I have enough space here. You know what? I'm just going to go to the next page, since I have all the space I want. And we'll just clear this off. And I just use the lines I've got there. I can just turn them around. All right, so I'm going to choose that y-intercept and that y-intercept. All right, and you get to pick the slope, right? So if you're graphing two parallel lines, right, pick the y-intercepts and pick the slope. I'm going to choose a slope. I'm going to choose a negative slope, since that one's already negative. I'm going to make the slope be m equals -1/3. That's what I'm going to choose. All right, so that means the next point is going to be down 1 to the right 3, down 1 to the right 3. I could also go up 1 to the left 3 if I have space. And now you use a ruler. I'll use a line tool because it's all I've got. And there's my line. All right, so now I'm going to do the same thing for the other one. I'll just use this line. That's conveniently already left here. All right, so I made the slope negative 1/3, so down 1 to the right 3, down 1 to the right 3, and I can go up 1 to the left 3, up 1 to the left 3 until I run out of space. And now let's connect to those points with a line. So if you're just going to be writing the equation in slope-intercept form, make the y-intercept something easy. If you're going to be doing point-slope, choose any point you want. Choose any 2 points you want. It doesn't make any difference. Can't get the end of it. My line's too long. Where does this end? There we go. It will make it. This is not the part I want to take too long. There we go. Well, sort of. Yours will be so much better because you'll use a ruler and you won't have a line. There we go. Line tool that you move one side, then the other side goes up. All right, so my y-intercept, my slope is negative 1/3. My y-intercept here, which would happen to my line? Did I move the background or something? There. My y-intercept is 1, 2, 3, 4, so 0, 4. That's the equation, y equals negative 1/3 x plus 4. Remember slope-intercept form, y equals mx plus b. So m is slope, and y equals y-intercept. And then right here, I have the point 0, negative 1. So this is y equals negative 1/3 x minus 1. And there we go. We're done with those two. That one. Let's go to the next one. So now we're on number 6. Actually, you know, you don't have to draw another pair of parallel lines. You can just stick with those to do number 6. Graph a transversal through the parallel lines and label. So, and I just put it, and you can put it anywhere you want. And because it's blending, kind of blending together with everything, should I? Oh, I guess that's fine. I think you can see it from the other ones. I could change its color. Oops, but first I have to get rid of the line tool. Here, we'll make them stand out. So the parallel lines are in orange, and the transversal is in purple. So in terms of labeling it, it doesn't say to write the equation, so you can just label transversal. Transversal is just any line that intersects two other lines. Oops. They don't have to be, I'm too close to, there we go. I'm too close to my recording box. They don't have to be parallel to one another. They just have to, intersect two lines. In this case, though, they're parallel, right, because we made sure on the coordinate plane. Number 7, alternate interior angles labeled. All right, so let's label those alternate interior angles. To me, it doesn't matter how you do them. You could color code them. You could number them. Whatever creative thing you want to do. Maybe I'll color code them. All right, so this is alternate interior angles. So, or you can write alternate interior angles next to it, whatever is clear. So the alternate interior angles are those angles right there. They are between the parallel lines on opposite sides of the transversal. Those are the alternate interior angles. And in this case, this angle here is congruent to this angle, right? That's why they're called alternate interior. The congruent ones are on opposite sides, and those two are congruent. So this will be my alternate interior angles. And then alternate exterior angles, I guess I'll just label those in green. So actually, yeah, that's fine. I was gonna, maybe I should label in blue, just because I already got so much green up there. This assignment goes by pretty quick. So those are a pair. And they, whoops, how did I get to be so far out? There we go. Those are a pair, And this angle is congruent to the other angle with 2 arcs. And this is the other pair. And these are congruent to the angles with just 1 arc. There we go. And that was our alternate exterior angles. So as I was saying, these aren't taking too long. We're already up to question number 9, halfway. All right, so same side exterior, interior, exterior angles labeled. Well, I guess I'm going to have to use another color or a number or something. So I guess I'll use a number now. And I'll write in purple. All right, so these would be the same side exterior. And for you, however you want to label it so it's clear to me. So maybe we'll call it angle 1 and angle 2. That might be easier now, labeling them. So angle 1 and angle 2. And you can number all of them and just list the numbers. I lost my purple. Angle 1 and angle 2. And then we have another pair of alternate exterior angles. Same side exterior angles. And that would be angle 3 and angle 4. And those are not congruent, but they are supplementary. Those are the same side exterior angles. We don't really use those too much. And then let's label this angle 5 and angle 6. And then we have another pair, angle 7 and angle 8. So the same side interior and same side exterior, they're either outside the parallel line, outside the lines, or inside the pairs of lines. And if the lines are parallel, they are going to be supplementary to each other. So angle 7 and, angle 7, let's write that better. Angle 7 and angle 8 are the same side interior angles. And by the way, colorful is nicer. All right, and then corresponding angles located, labeled. And that's the last thing I'm going to do on this slide. All right, so the corresponding angles, they are in the same relative position on the line, same side of the transversal. So since they're numbered, I'm just going to use a number. Angle 3 and angle 8 is one pair, right? Because they're both above and to the right. Angle 7 and angle 4 is another pair because they're below and to the right. Angle 1 and angle 6. And because they're above and to the left, and angle 5 and angle 2. They're below and to the left. And these are corresponding angles. Uh-oh. I don't have enough space. How about we write above? And as soon as I do that, nope, I put it in the wrong spot. Put the eraser in the wrong spot. I'm waiting for the pen to come up. And these are corresponding angles. So in the next video, I'll start off with number 11, a pair of perpendicular lines with the equations written in slope-intercept form, and the rest of those, the triangle things. All right, so bye for now.